Welcome to UVU CS3060 Lecture 6.5, where I demonstrate how to implement a critical section problem solution using hardware. Let's get to the code. So if you remember, we came up with a solution used in the video 6.3 for using Peterson's solution. Mind you, we had to use a little bit of hardware here, but in general, Peterson's solution works fairly well. What we're going to do is, instead of Peterson's solution, we're going to remove all this code here, and we're going to provide a lock that doesn't use Peterson's solution. In fact, we'll just get rid of all of this here. Instead, what we're going to use is test and set. And for this, we're going to use a character variable. We'll call this lock. And we'll set it to 0 to start with. Basically, it's in an unlocked condition. Now, in order to do this, we're going to go ahead and use one of the atomic built-ins. If we take a look at the list of atomics, there is in here an atomic test and set that takes a pointer to a variable and will return whether or not that was whether it matched or whether the value was set when inside the operation. And we'll use this to test for a lock. So let's use atomic test and set. And what we'll do here is we will use, instead in the lock entry, we're going to go ahead and perform a while loop. It's going to be an idle loop, but in here we'll do atomic test and set. Now, we don't take a thread ID anymore. What we'll do is we'll take the lock, and we'll call this plock here. We'll pass it the plock into atomic test and set. Remember, it has to be a reference. And then we'll use the atomic sequential CST. This is the toughest or most strict locking mechanism that they have. There are several locking mechanisms that, if you're more interested, you can read up on. But that's it. That's all that's necessary to use test and set. We use the atomic test and set on plock. If lock is set to 1, it's going to continue to be set in 1, return a 1, causing this loop to just run infinitely until somewhere in the code, lock is set, we'll do plock, is set to 0. And that's what we'll have the exit do, is we will have the exit function take a reference to the lock, and it will set that lock to 0. And that's all we need here for this particular solution, to use this particular piece of hardware. We do need to change our lock entry and lock exit so that it's sending a reference to our lock variable. So let's go ahead and change that. Both places, both in the increment and in the decrement down here. So we delete that. Send it a reference to lock. And our exit is also sending a reference to lock. So there we go. Both are using the same lock variable. Both are protecting their critical section using lock entry and lock exit. And our lock entry and lock exit functions are extraordinarily simple now. One uses the atomic instruction of test and set. So let's go ahead and save this. And let's see if it runs. We'll build it. It builds successfully. And we run it. And as you can see, using the atomic test and set, we now get a count of 0. We can do the same thing using a similar atomic. I'm not going to demonstrate it. I'll leave this as an exercise for the viewer. But there is an atomic function called atomic compare exchange. This is the compare and set. You just simply send it in a pointer to a variable, what you expect it to be, If it does have that value, it will set it to the desired value. Normally you'll set the weak variable to true, or to false, so that it's using the non-weak algorithm. And then you can set these to the sequential CST, the mem order to sequential CST. So that brings us to the end of lecture 6.5, where I demonstrate how we solve the critical section problem using hardware.